So this video is going to cover metallic bonds, including the definition, the different properties, and one little subset having to do with what we call alloys. So metallic bonds, I want you to understand that these are the bonds that are in a piece of copper. So if I have a piece of copper wire, how are all of those copper atoms joined together? If I have a piece of aluminum foil, how exactly are those sticking together? Okay, so it's going to be what we call stickiness, or how does it organize itself? Okay, most metals we're going to talk about are solid, so we're going to go back to that idea of solid structure. So metallic bonds are bonds found in metals. Okay, that's going to be how we define it. So again, piece of aluminum foil is pure aluminum. There is nothing else in there but aluminum. And so how do they bond together? The definition of metallic bonds is as such. The definition is a cation surrounded by what we call a sea of electrons. So a cation being a positive ion surrounded by a sea of electrons, So I'm going to draw you a picture of iron. Is going to be my example. Iron is Fe. And so if I am drawing what we call a cation surrounded by a sea of electrons, iron can have a +2 or a +3 charge. So let's say we have a +3. If we have a +3, that means it has lost 3 electrons. And so these electrons are surrounding these cations, okay? And what I kind of circled here is kind of what I call a sea of electrons effect, meaning these electrons can flow easily between these cations. So these electrons do not belong to any one iron atom. They are distributed through the whole structure. So the sea of electron, if you think of it, again, these waves of electrons can move freely. They are not bound by any one particular atom, so they can move a lot, which is going to lend itself to some interesting properties of metals. So again, a cation surrounded by a sea of electrons, So because we have that structure, there's some unique properties to metals that you probably already know. So, pause for a second and think of what are the things that we know metals do compared to other substances. So one thing in particular is they are good conductors of electricity. They're also good conductors of heat. So you could write in heat as well. We know that because at home, we probably have metal pots. They get warm when we heat them. They conduct very well. So that is a property of metal. That's a property of a metal. There's two other words that you might not know, or maybe you know. If I take a metal and push it into a sheet, so like a piece of aluminum foil, that is what we call malleable. So the metal is malleable. If it is something that can be drawn into a wire, that is called ductile. So malleable and ductile are two descriptive words that are used to describe metals. And that is also due to the fact that the structure has those electrons, what we call delocalized, so they are freely moving. So you can push them into a sheet and still have the aluminum. It's not going to destroy anything there. Metals have high and low melting points. So again, melting point is going to be abbreviated MP. We've been using that for a couple different things. So you can't necessarily say that all metals have high melting points. Of course, the metals we use on our stoves are going to have high melting points because we don't want it to melt while we're using it. But there are plenty of metals like gallium, for instance, that could actually melt in your hand. You have enough heat in your hand to melt it that way. So you can't assume just because it's a metal, it is a high melting point. And most metals are solids, okay? But there is one metal that you might know that is not a solid at room temperature. And we're always talking about 25 degrees Celsius room temperature for this one. So do you know of a metal that is not a solid at 25 degrees Celsius? Well, the one that we should be familiar with that is a liquid is our friend mercury. Okay, so mercury is a metal. It does conduct. It is in liquid form at 25 degrees Celsius, 25 degrees Celsius. So a subcategory of metals is something called alloys. Reason bringing this up is because in your normal everyday life, not everything is a pure piece of aluminum or pure piece of copper. It might be a mixture of metals. And the reason you mix things with metals is to change their properties. So maybe you want it to have a higher melting point, or you want it to be stronger or weaker, whatever it happens to be. So the only requirement for an alloy is that you have at least one metal in the mixture. So you could have multiple metals. So you could have 2 or 3 metals in there, but at least one of them needs to be a metal. At least one of them needs to be a metal. So don't spend too much time getting into this, but I thought that this was a pretty nice graphic to show. They're called 2 different kinds of alloys. One is called the substitutional alloy, and another one is called an interstitial. So if we just have a pure metal like we do here, these circles that you see are just going to be individual iron cations, and then you have the electrons flowing between. That's the only thing I don't like about this picture, is they don't really show the electrons. Substitutional are going to be alloys that are about the same size. So if you substitute one atom in for another, you're going to see the blue versus the red here are about the same size in terms of their diameter. So those are going to be what we call substitutional. So one atom substitutes in for another, and they just repeat back and forth depending upon what it is. So some examples of that are brass and bronze are what we call substitutional alloys. Another one is called an interstitial alloy. Those are going to be, an example of it would be steel. So you could have iron as the red circle here, and then maybe carbon, something smaller. So if you have a smaller substitution and you are trying to, again, maybe one way to think about it is you are filling in the gaps here. And so this is the green one that you see in this picture is a smaller atom versus the red one. So interstitial means it kind of gets in the middle of it. So it's not a substitution. And then you could have both, meaning this one is stainless steel is one of the examples they gave. So you do have a substitution of an atom, but you also have an interstitial. And this could be, again, to change some of the properties having to do with strength, or with stainless steel, maybe so that it doesn't rust. Any kind of property that you might have that you want to get rid of or add to the mixture. So if you think of your everyday life, you might have some ideas in your head of some alloys. So we have brass, bronze that we just saw, steel, and there are different kinds of steel. But you also have sterling silver. Maybe you might have some flatware, some utensils at home that might be sterling silver. And then the other one that is kind of a weird thing is your dental fillings, if you have dental fillings. They used to make dental fillings actually out of mercury. I used to have 1 or 2 fillings, and then they've stopped using it because mercury not good to be in the human body for a long period of time. So dental fillings is another example of an alloy, and there's plenty of other ones. So I just thought of some examples that usually come up in discussion. So what makes up brass? Well, again, this is not going to be something that we talk about, but brass is a mixture of copper and zinc. And by the way, it happens to be a substitutional alloy. Steel is iron plus something else. It depends upon the kind of steel. Sterling silver is silver and copper. Bronze is copper and nickel. So again, this is not going to be something we assess you on necessarily, but again, these are normal everyday stuff that you might encounter that are alloys that do have a metal in them, but they might have multiple metals in